last thing from this set of notes is looking at different types of applications. And we're going to do more with applications as the chapter progresses. But the different types of applications you can have are you can be given a numerical table, which is the first type we're going to look at. You can be given a graph, which is the second one. Or you can be given a function expression, algebraic expression, which is the third one. So I'm going to do each one of those, an example of each one of those. And we're going to do more, like I said, as the chapter progresses, we'll do more of these examples. We're just going to hit one of each type just to remind you of the different types they can have. So the first one is the numerical table case. So this means I'm given a table of information and I'm going to answer some questions based on that table of information. So the table of information, so we've done an observation here. John did jumping jacks, and it was observed every 10 seconds how many jumping jacks he completed by that time. Right, so 10 seconds he completed 11, so on for 90 seconds. After 90 seconds was over, he had completed 100 jumping jacks. All right, and so there's the table of information that goes with that. So the first one is, well, there's two variables. There's time and jumping jacks. One of them is the independent variable. One of them's the dependent variable. It means one depends on the other, right? So one has to be a function of the other. Time, whenever you're given time, time is always the independent, right? Number of jumping jacks completed depends on what time I pick. At time 0, he didn't complete any. But at time 50 seconds, he completed 53 or 56. And so number of jumping jacks depends on what time we look at, what time we look at in our study. And so time is the independent variable, which would be the x variable. I'm going to be a little more creative. I'm going to do t for time, and that's in seconds. Which means the number of jumping jacks is my dependent variable, right? Number of jumping jacks depends on what time I select, which would be the y value. I'm going to use capital J for my notation. And so my function notation, so it's the independent, dependent, right? The function. I'm not going to ask you to graph. Asking graphical questions of this type is too hard virtually. And so I'm just going to skip that. We're not going to worry about it. You will not be asked to graph these, so you can kind of scratch that out. We're not going to do it. We're just going to set it up and ask questions about it. Alright, so my function notation, I'm going to let my function be j of t, where that function represents, so this function represents, this is the function, where it's the number of jumping jacks after t seconds. That's what the function represents, number of jumping jacks given a time input. Right, the next question, domain and range. So the domain goes with the time, the range goes with the jumping jacks, JJ jumping jacks. And so, well, what is my time? I can only use the time I'm given. Now, they took the time every 10 seconds, but there are time intervals in between, right? At 5 seconds, he might have completed, 6 jumping jacks. At 15 seconds. And so the time interval is the time given, 0 to 90 and everything in between. And so my domain, there's two ways you can write this. If you use interval notation, 0 to 90, include 0, include 90. Or you can use time as between 90 and 0. Either one of those are fine. They mean the same thing. It means my t value is between 0 and 90. And I can have 0 and I can have 90, right? I have 0 seconds, I had 0 jumping jacks. I had 90 seconds, I had 100 jumping jacks. Alright. Range goes with the number of jumping jacks. Which I have to look at, the number of jumping jacks, which would be, looking back at my table. So number of jumping jacks goes from 0. And there you could 1.5 jumping jacks if you're halfway through the jumping jacks. So I'm going to include the fractions. I'm going to say I can complete anywhere from 0 to 100. And I can do a part of a jumping jack if I stop midway. Or you can say jumping jacks are less than or equal to 100, greater than or equal to 0. Alright, either one of those would be fine. Okay, so now just some questions based on notation. So the first one just asking you for a notation. So the first one is just, what does this mean? So if I give you j of 40 equals 45, what is that function notation telling me? Well, there's two number parts. So when you're interpreting it, you should always interpret both parts, and you should always interpret it with correct units, right? It's kind of a statement. And so what that j of 40 equals 45 is, well, it's after 40 seconds, John completed 45 jumping jacks. Read that. All right, the next one is asking you to solve for it. So find j of 70. All right, so that means 70 seconds he completed how many jumping jacks? Oh, I have to go look at my table. At 70 seconds, he completed 79 jumping jacks. All right, so the answer is 79. I'm going to just use JJ for jumping jacks. All right, the last one, find the T when J of T equals 23. And so this one's asking for at what time did John complete 23 jumping jacks? So when did he complete 23 jumping jacks? So I go up and look at my table and I find 23 jumping jacks. Well, there's the 23 jumping jacks. He completed them in 20 seconds. So the answer is T equals 20. Alright, so those are the sort of, again, the numerical table case. And again, like I said, I'm not going to ask you to graph these. It's just too hard to do. And so you just have to be able to use it, interpret it, understand what the domain and range is, understand what the function notation is, be able to explain the answers to me. Alright, and so there's a numerical example. And so the next video we'll do a graphical example.